Okay. All right. So we're going to start by sharing today, and we're going to share a view of the entire universe with you. Now, the way this works, I want to show you guys everything from where you sit all the way to the end of the universe and beyond. There may be even more than just our universe. So this is the view that we have from the Milky Way galaxy. We live in a galaxy, and we live in what is called the solar system. The name of the sun is Sol, S-O-L. That's the sun, Sol. So the solar system comes from Sol. And the solar system is the sun. The sun is not a planet. The sun is a very special object. It produces so much energy, it's unbelievable. In 1 second, the sun produces as much energy as the United States will in the next 500,000 years. Just 1 second, right? So it's an incredible object. Around the sun, we have 8 planets. And these 8 planets, the third of which is the Earth, orbit the sun. And so every day you wake up, we're in a different location. When you woke up this morning, you've moved. You moved quite a bit. Moved hundreds of thousands of miles from when the class started. Just when the class started, like a half an hour, 1 hour ago. So we're moving really fast. All right, so let's take a look now. The first view I'm going to give you is this. This is atoms. Now, atoms are something that started by the Greeks. Greek philosophers thought that if you just keep cutting things like, let's say, a piece of wood, eventually you get to something that you cannot cut anymore. And they call that atomic. So an atom that we know of today is got a nucleus. Inside the nucleus of the atom, there is something called a proton and a neutron. The difference between a neutron and a proton is not very much at all. In fact, the proton and neutron are identical, except for the fact that the proton has what we call a charge. Now, a charge is, like electricity. You can imagine it like electricity. But tiny, tiny amounts of electricity. It's inside the proton, but not inside the neutron. So they're identical things. Now, inside of the protons and neutrons, there's also finer particles. These are called quarks. Each proton is made of 3 quarks. 2 up quarks, they call it, and 1 down quark. So that makes up a proton. 2 up quarks and 1 down quark. In a neutron, it's the opposite. It's 2 down quarks and 1 up quark. So there's finer things than the protons and neutrons. So they're not elementary particles because there's more stuff in them, right? They make up the nucleus of the atom. Now the electrons are much, much smaller, maybe even have a size of 0. We'll discuss things like that later. But the electrons orbit the protons, and their orbits are very, very complicated, to a point that we think that maybe the electrons have some form of unit of consciousness, because they do things everywhere and they know exactly what to do. Doesn't matter where you are, in this side of the universe or the other side of the universe. They're that intelligent. They know exactly what to do. And most of the light that we see comes from the electrons. When the electrons move closer to the protons and neutrons, they emit a photon, which is the particle of light. That's energy. So electrons moving closer to the proton, they give you light. And they have to take away the light to move away from the proton and neutrons in the nucleus of the atom. All right, so that's just an atom. It's very, very small. We say, how small is an atom? Well, we have human cells. Approximately 100 trillion human cells make you where you sit. So you are a collection of 100 million human cells. Each human cell is made of approximately 100 trillion atoms, right? So in a single cell, there's 100 trillion atoms. That should pretty much tell you how small an atom is. You can't see a human cell, but you can see it under a microscope. So when you see a human cell under a microscope, you're looking at 100 trillion atoms. That's quite a few. Now, what is a trillion? A trillion has a 1 with 12 zeros. So there's 3, 6, 9, and 12 zeros. So 12 zeros is a trillion. 9 zeros is a billion. 6 zeros is a million. And 3 zeros is obviously 1,000, right? So 1,000, million, billion, trillion. And what comes up after trillion is called quadrillion. This is 1/10 of a quadrillion, which means 100 trillion atoms in a human cell. And there's also 100 trillion cells in your body. That's pretty amazing. So how many atoms are in your body as we speak? Well, there is 100 trillion times 100 trillion atoms in a body. That's quite a few atoms in a body. It's pretty amazing. Now, everything is made of atoms that we see. So you look at the sun, it's made of atoms. The sun sends out these photons that we see in a human eye. So the photons, light, was created by the atoms. This is the Earth. Tiny, very, very tiny. We all live on this Earth, and there's 7 billion and some change people that live here, with all the plants and animals and everything else. The Earth is fairly large, right? If you go around the Earth, that's approximately 25,000 miles. All right, 25,000 miles you can go around the Earth, which is approximately 40,000 kilometers. That's the circumference of the Earth. If you just keep going around the Earth, that's how big it is. Now, in relation to the sun, right, it's tiny. You can put 1 million Earths inside of the sun. So there's quite a few. Almost 1 million Earths fit inside the sun. Now, in turn, the sun is what is called a star. All the little tiny lights you see in the sky, almost all of them are stars, with the exception of just a very, very few of them we call planets. So these planets are much, much smaller than stars. Stars are gigantic, and they make light, and everything that you see in the sky, with the exception of, like I said, just the 5 of them, that you can see with the human eye, they're called planets. The rest of them are all stars, which means suns. These are all suns that we're looking at. And these suns are born in places where there's a lot of gas, and they're born in clusters. So one cluster of stars, when it's born, maybe has 1,000, 10,000 suns that are born together. Now, when these suns are born in these dusty, gassy places, they're born nearby in a place called the Milky Way galaxy. Milky Way galaxy is our home. So the solar system exists in the Milky Way galaxy with something like 200 billion other suns. So this is our island. You know, we're far away from everybody else in this Milky Way galaxy, and we're approximately here about 26,000 light years, and we'll get to the light years in a few minutes. We're 26,000 light years away from the center of the galaxy. Light year is a measure of distance, which is a distance light travels in 1 year. So if you shine your flashlight in space tonight, it'll travel 1 light year in 1 year. So how far light travels in 1 year is called light year. All right, now this galaxy of ours is not alone. In the universe, there's quite a few galaxies. These are all galaxies. If you look at a big picture of the universe, there's quite a few galaxies in the universe. We think something like about 100 billion to 200 billion other galaxies besides the Milky Way galaxy. So it's a big place. Approximately the size of the universe is approximately 96 billion light years, which means light travels from one side of the universe to the other side of the universe in 96 billion years. So 1 light year, if you want to think about it in miles, is about 5.8 trillion miles. Remember, trillion has 12 zeros. Now, it appears that what we know today, we think we're correct, but we might even be wrong, it appears that all these galaxies that we just talked about, including the Milky Way, are lined up in these things called filaments. You see, guys, this is like a filament. A filament is like the spider's web. So if you're looking in your garage after a few months of not cleaning it, you can see all the spider webs. The spider webs are made of something called dark matter. This dark matter is invisible. You can't see it. It only has gravity. So it's an invisible particle that has gravity. It doesn't interact with light. It doesn't interact with matter except through gravity. So it's invisible. We can't really see it. And it's most likely in your room right now, like in Francisco's room right now. There's there's dark matter inside his body. Is probably dark matter is pervading you most likely. So this dark matter forms these filaments. Now regular matter, like us, we're made of atoms. These atoms make up the Earth and the Sun and the galaxy, and the galaxies in the universe. They follow this dark matter in that filament that the dark matter is flowing. So these are all every little tiny dot that you see here is a galaxy. So that's a big picture of the universe. Lots of galaxies formed in these filaments. Some places there is no galaxies. We call these the voids. So there's a void here, there's a void here, there's a void here. All these dark areas are voids. Even a bigger picture, this is more like the neighborhood of a few, let's say, billion light years. But if you look at a bigger picture, you can see this. That's what a big picture of the universe looks like. These are all made of dark matter filaments that attract all the galaxies, and so the galaxies also flow in the form of these filaments. And so that is the shape of our universe, a big universe filled like that. Now, does it have an end? Oh, we think it's about 96 billion light years in extent, but it may be endless. It may be infinite. It may have no end at all. So there's still a debate about that. Now, if there's an end, there's talk now that maybe before there was a universe of ours, there were other universes. And those other universes gave birth to our universe. And then our universe, at the moment, as we speak, is giving birth to other universes. So this birth may be going on, and there may be multiple universes we call multiverse. So all these multiverses, they have those filaments, they have galaxies, and it's possible that maybe they're not the same as ours. Maybe they don't have galaxies. Maybe the laws of physics, the laws of nature, maybe they're different in these universes. Of course, we don't know anything outside of our universe. All that we can detect right now is our universe. But maybe someday we can detect what's outside of our universe as well. Okay, this is a picture that a Hubble Space Telescope took of an area of the sky that appeared to be void of anything, no stars or nothing else. So they pointed the space telescope for 30 days. They soaked the detectors of the space telescope with light to see what they can see. And so these are some of the farthest galaxies that we can see. When we look at these, what we see is the universe when it was very, very young. See, now these galaxies right now, they're very, very old. But when you look at them from our position, because it takes light so long to get to us, they appear to be very young. So their light left something like 11, 12 billion years ago, and we just see it today. But right now, they are 12, 13 billion years old already. But we can't see them as old galaxies, we see them as young galaxies. Okay, now I'm going to stop sharing, and I'm going to stop recording also.